Okay, so today we're going to talk about something called implicit differentiation. Up to this point, whenever you've taken a derivative, you've always just taken your basic derivative. So here on the left, if we took the derivative of y, we would get y prime, and we would get 3x squared plus 6x minus 2. Okay, so what's made this different than what you see over on the right side there is that your original function always had a y equals, and then it was easy for you to take the derivative. If you look on the right, that does not say y equals. Now, the one on the right isn't that difficult for you to get the y by itself, but then you're going to have a square root in there, and you're going to have a plus or minus with that square root, so that makes it a lot more confusing. So we have something called implicit differentiation, and what that will do is help us find the derivative, but in a different way, and it will make it a little bit easier than if you just went ahead and tried to get the y by itself. You'll see when you get to some more complex problems. So this is the way it goes. So you start taking the derivative of x squared the way you would normally do it. Now, when we take the derivative of x squared, we get 2x. Then what we do with implicit differentiation is we write something like this. And what this is saying is the derivative of x with respect to x, dx over dx. Okay, the derivative of x with respect to x. Hold on a second, you'll understand. Okay, so then we're going to take the derivative of y squared. So it would be 2y, but now we just took the derivative of a y, and always with respect to x, okay? And then we take the derivative of 4, which we know to be 0. So here's the deal. So again, whenever we're taking the derivative of an x, we write dx dx. Whenever we're taking the derivative of a y, we write dy dx. Now, if you really think about this, dx dx is really just 1. So this is not necessary to write all the time. I'm just kind of showing it to you for the first time so that you know what to do. So really, then what we have is 2x plus 2y dy dx equals 0. Now you should know, because we've done this before, that dy dx is essentially derivative. And that's what it is that we're looking for. So basically what we're going to do is we're going to try to get this dy dx by itself. So I'm going to start by moving that 2x over. Okay. Pen. And we're going to get 2y dy dx equals negative 2x. We're still trying to get that dy dx by itself. So what we're going to do now is divide both sides by 2y, divide by 2y, and I'm going to have to squeeze the answer in over here. You see now that we get dy dx is equal to negative x over y. And there is your derivative. That's your answer. Okay, these the negative 2 in the numerator and the negative 2 in the denominator will cancel each other out. Okay, so if you also notice, your derivative does have an x and a y in it, unlike the first derivative up here, where your derivative was a y prime equals, or a dy dx equals, and it was just x's that you have on the right side of the equal sign. Okay, so that's another slight difference. All right, let's look at another problem. Okay, so now we're going to look at one that's a little more involved. So let's say I have x squared y plus 2y squared plus x cubed equals 10. Okay, now this one would really be a pain to get the y's by itself. Thus why we kind of do the implicit differentiation. It makes life a lot easier. Now you have to be careful here because we have product rule. So we're going to have to do the first times the derivative of the second. Now that's the derivative of y would be 1, but then we would have to write dy dx, okay, plus the second, which is y, times the derivative of the first, which is 2x. Now, I'm not going to write dx dx, because really that is just a 1. Okay, plus, and we're going to do the same thing again. Now we're going to go to the 2y squared, and we're going to take the derivative of that. So we're going to get 4y. Now, again, I just took the derivative of a y, so I write dy dx plus And now I'm going to take the derivative of the x cubed, which is 3x squared. Now again, technically, that is dx dx, but we don't have to write that. Equals, and then the derivative of 10 is 0. Okay, so there's your startup. Now this one's a little bit different. So what you're going to do now is you're going to try to get everything that has a dy dx, which would be right here, and we're going to leave those on the left-hand side of the equal sign. And then everything that doesn't have a dy dx, the 2xy and the 3x squared, are going to move over to the right-hand side. Okay, so then what happens is we get x squared dy dx. We're leaving that, and we're also leaving the 4y dy dx. And we're going to move, like I said, the other stuff. So obviously the signs are going to change. So we're going to get negative 2xy and then minus 3x squared. Okay? Now if you look at the left-hand side, they have a common factor. And that common factor is dy dx. So we're going to take out that dy dx, factor that out, and then you will get x squared plus 4y. And then just leave the right-hand side as it is right now. We'll deal with that in a minute. Okay, so really, the only thing that was done on the left-hand side of the equal sign was we just factored out the dy dx. And the reason why we did that is it's getting it more by itself, and now if you look at it to get it completely by itself, we can just divide by what it's being multiplied by, which would be the x squared plus 4y. And over here as well, x squared plus 4y. Okay, those cancel out. And there we go. We've got an answer. dy dx equals, remember that's the same thing as saying derivative equals. And then we've got negative 2xy minus 3x squared. And that whole thing is over x squared plus 4. Oh, come on now, pen. 4y. And there's your answer. Okay, so that's basically the way implicit differentiation works. Now, what I'm going to do is at this point, if you feel comfortable, then just go ahead and you have a ditto there that you're going to work on. If you're still a little uncomfortable, then I have one more example that you can listen to if you so choose. All right, so if you're looking at your worksheet, the first example says x cubed plus y cubed equals 18xy. All right, so I'll just do the first one with you. So again, we take the derivative of x cubed, which would be 3x squared, technically dx dx, but again, I'm not going to write that, plus 3y squared. Now, I did take the derivative of a y, so I want to write dy dx. Okay, equals. Now here on the right-hand side, you have product rule. I'm going to group the 18 with the x and then keep there we go. Sorry about that. And then keep the y by itself. Okay, there we go. All right, so I'm going to have 18x, right, the first, times the derivative of the second, which would be dy dx, plus the second times the derivative of the first, which would be 18. Come on, silly pen. Okay, now, again, the goal is to get the dy dx's on one side. Okay, so that would be these things that I'm underlining, and they're not on the same side right now. And then the 3x squared and the 18y, I want to get those on the same side also. So I'm going to move the dy dx's to the left, which means the 18x dy dx is going to move. So I'm going to have 3y squared dy dx. Now because I'm moving that 18x, that's going to be subtracted. 18x dy dx. And then everything else is going to the right side. Now the 18y is good. It's already on the right side, so I'm just going to leave it there. But I'm going to move that 3x squared, so that's going to become minus 3x squared. Okay? And like I did on the last problem, now you see that you have two terms on the left-hand side with the dy dx, so you're going to want to factor that dy dx out. So dy dx dy dx parentheses 3y squared minus 18x and then on the other side, we just bring it all down. Okay? All right, and then last but not least, then all you're going to do to get the dy dx by itself is to divide by what it's currently being multiplied by, which is the 3y squared minus 18x. So over here, we do the same thing, 3y squared minus 18x. Okay? And cross that out. All right, now, the only difference over here with this one is you do technically have a common factor, both in the numerator and the denominator, of a 3. So if you wanted to, you could go ahead and factor that 3 out, or divide everything by 3. So that would give you 6 minus x squared in the numerator, and then in the denominator, you'd have y squared minus 6x. Okay? And then that is your answer. So there's implicit differentiation.